Go ahead and get started. Thank you all for joining. If I could get just a quick show of hands, make sure that you can hear me okay. Just click the little hand button so that I know my voice is coming through all right. Okay, great. Thank you, Ian. My name is Perry Krug. I am a senior solutions architect for Couchbase. I'm currently based out of our London office, looking after our European and UK customers and users. So I'm really excited to have everybody here today. If you haven't heard, although I'm sure you have, we just launched the GA release of our 2.0 version, and so I imagine there are lots of questions and lots of things you want to learn and talk about today. I'm going to spend just the first few minutes, the first half an hour or so, going through an introduction, an overview of the new version, and then I'll open it up to any questions you may have. Depending on your level of experience and knowledge with Couchbase, our 2.0 version is a NoSQL document database. Previously, it was really just a key value database that has been in production for about 2 years and gained a lot of success in some very high-profile customer environments running in production. And with 2.0, we are adding a number of features that have been widely requested by our customer and user base. Before I get started with that, just wanted to set up the idea that Couchbase and NoSQL really seek to promise four main capabilities and features of a NoSQL database. We believe that any NoSQL database that's being used in a production or mission critical environment really needs to meet these four characteristics. The idea of easy scalability, being able to grow or shrink your cluster without any downtime and without any application changes. Consistently high performance, regardless of what operations or actions your application is doing to the database. It should be able to provide consistent throughput and consistent latency to those requests. These databases must be always on, 24 hours a day, 365 days a year, because these applications that are running on top of them are providing the same level of uptime to their users. And then lastly, a flexible data model, making it very easy to change your data structure and have different unstructured types of data living side by side. So Couchbase really believes that this is what NoSQL is all about, and we believe that Couchbase server really defines itself by these four characteristics. Let me just skip through a couple slides. Some of the high-level features for Couchbase: built-in clustering, built-in replication and auto failover, the ability to maintain and upgrade the software without any downtime, very simple clone to grow, scale out, horizontal scalability, a built-in caching layer for very high performance, a very simple and well thought out monitoring and administration UI, as well as REST-based API for pulling all of that data into some external system. And then lastly, a suite of SDKs for a variety of languages. With 2.0, we bring native support for JSON data, and apply to that indexing and querying that's based off of incremental MapReduce. And we also added a cross data center or cross cluster replication feature. So I'm going to walk through all of these, try to get through it kind of quickly. This session is being recorded, so you can feel free to view it afterwards, but I do want to leave enough time at the end for questions. A quick look at the architecture of Couchbase Server. We split this up into two components. On the left, you have the data manager that is responsible for all requests and data access from the application. And on the right, you have a out-of-band cluster management system that is responsible for gathering statistics and holding the cluster together. If we take a look a little bit deeper, on the left side, you see there is a persistence layer with an object cache on top of that. And this is all based off of memcached in the caching layer and based off of CouchDB on the persistence layer. And then on the right-hand side, we have our REST API, we have the management, the process monitor, the statistics gathering, and all of this is based off of Erlang OTP, which is a very widely deployed, robust clustering and distributed system management layer. A quick look at what a deployment, Couchbase deployment looks like. Using one of our client libraries, your web application connects to the cluster manager, and gets and maintains a connection with the cluster to know about any topology changes. And then each application server actually sends its data directly to the nodes that are responsible for that data, so that we avoid the need for any routing layer or any proxy layer. And each of the application servers actually does the load balancing for us. Okay, let's take a look at some of the operations. So every operation that we do on an individual document is done between a single application server and the single Couchbase server that is responsible for that data. So you'll never be talking to one node and getting the data from another one. Your application server will always talk directly to the Couchbase node that is responsible for that piece of data. And all the while, all of your application servers are talking to all of the Couchbase servers all at the same time, getting all of the different pieces of data. So when a write comes in, it's first written and acknowledged into our managed caching layer and replicated out to 1, 2, or 3 other nodes, and then drained down to disk for persistence. So we have replication for high availability, that is RAM to RAM, and we have the disk persistence layer that gives us both further robustness and also the ability to do operations on the data on disk, which we'll see in a minute. An update operation similarly updates the data in cache. It's then also replicated out and persisted down to disk, where it's replaced as well. A read operation, very simply, a request is made from the application server, and if the data is in cache, sent directly back to the application without having to touch disk, without having to talk to any of the other nodes in the cluster. Going back to the write process, as data fills up RAM, at some point we need to actually remove data from RAM after it has already been persisted to disk, in order to make space and keep the RAM usage in check. We are not using a naive disk caching by the OS that would end up swapping itself. We have a very explicitly managed object cache that knows exactly what data is in RAM, what data is not in RAM, what data has been persisted to disk, and which data has not yet. Following along that line, if we took then a request for that data that had just been ejected to disk, the request comes in, the data is copied up off of disk and sent out of the managed cache again, and the data will stay in cache as long as it can, or as long as there is RAM available and the application is accessing that. Taking a look at how this applies across a cluster, everything we just looked at is the individual node operation, and all nodes are really acting independently, but it's the clustered system that allows them to provide the power and availability to the application. So if we have 3 nodes here, and the data is, you'll see, evenly distributed across all of them, it's also replicated in the background. Our replicas are not available for reading or writing. We don't need to scale our reads by replicas because our managed caching layer can provide such high throughput. Hundreds of thousands of operations per second on a single node is far sufficient for any application. And so we don't need to have more nodes just for replication, just for read scaling. Our replicas are there for high availability. When the application servers come online, they contact one of these nodes of the cluster, get a cluster map, which basically tells them the topology of the cluster and where the data is located. And then every read, every write, every update, and every delete is directed right at the server that owns the data. So when both application server 1 and 2 want to update a piece of data, they're talking to the same node. And this way we maintain our strong consistency. Couchbase Server is an immediately consistent and strongly consistent system. So you always read your own writes. You're always talking directly to the node that is responsible for handling that data. And all of these servers are actively participating in that. So Couchbase Server is active with all of the nodes. There's no standby nodes. There are no warm replica nodes. Everything is, all the resources are being actively used to serve the application. When it comes time to add nodes to the cluster, the first thing that happens is they come online in a very simple one-click operation. They get associated with the cluster, but as you see here, they're not actually handling any data. When the administrator is ready, after he has added or removed multiple nodes at once, a rebalance operation is kicked off, which is the process of moving some of the active data and some of the replicate data onto these two new servers. The application server is updated with a new cluster map, and the next access is directed at the new server that holds the data. All of this happens online. It happens incrementally, so as soon as you start the process, some of the data is being moved and made active on the new servers, and it's done without any loss of performance and without any loss of availability to the application. We use this operation primarily to scale out the cluster, but this rebalancing also allows us to do online upgrades, online hardware refreshes, online removals of malfunctioning nodes, all without ever taking the application down or affecting its performance. The last thing to look at is about a failure of a node. If we imagine application servers are accessing server 3 and server 3 fails, there are going to be some requests that have to fail to it. They've already been sent over the wire. They've already been in flight. Once that is detected, though, the replicate data that was residing elsewhere in the cluster is immediately made active. The application servers are updated, and the next time you want to access that data, it goes to the replica copy. Keep in mind, we don't recreate replicas at this point because that would put added load and added data into a cluster that's already downsized. And so after this, the administrator can come in and re-add this server or add a new server, and a rebalance will redistribute the data and re-replicate it. So all of this that we just looked at all up until here is really has been part of our product for the last 2.5 years, and has really proven itself in production in very high scale environments. So now we're going to take a look at what was added to 2.0, really building off of this same well-architected, well-performing base. First of all, we have indexing and querying. So now with Couchbase Server 2.0, when you store JSON data, you can create pre-materialized views that are automatically built up and automatically maintained that you can then query across the entire data set. You can define primary indexes, secondary indexes, complex indexes, and we even have reductions that allow you to do things like counts and sums to provide the reduce part of a MapReduce. This is an incremental MapReduce, so it's not the same as Hadoop style, where every job you run has to process the entire data set. Our incremental MapReduce is keeping the data, keeping the index up to date with every individual document change or update or deletion without having to reprocess the entire set. So it's much faster and it's much more efficient to use as an indexing system. Keep in mind that the indexes are eventually indexed, and the queries are eventually consistent with respect to your changes to the document. So you may write a document and it takes a little bit of time, a few milliseconds, a few seconds before it is updated and reflected in the index. And by separating these two processes, we can keep very high performance for our individual document reads and writes, and also provide very good performance on the indexes without having the two conflict with each other. So looking at a single node, again, when an application server writes a document, it's again put into the managed cache. It is also replicated out and persisted to disk. And once it's persisted to disk, it's available to be picked up by the view engine and processed into the index. So this all happens automatically, but it does come off of disk, and so there is a bit of a delay between when it gets into the cache and when it is available in the view. If we take a look at how this operates across a cluster, every Couchbase server maintains its own set of indexes. There's both an active and a replica index kept up to date, so that even in the event of a failure, you have that data available in the replica indexes. When the application server makes a request, it can make that query to any one of the servers, which then any one of the Couchbase nodes, which then distributes the request to all of the nodes within the cluster, gathers the responses back up, and returns to the application server as if it were a single logical database. There's no need ever for your application server to know where the data is or how it is or which node is responsible for it. From the developer's perspective, from the application's perspective, this is all one logical database. Okay, the next new feature in 2.0 is our cross-data center replication. It is a linking of two separately managed clusters. So each cluster can be differently sized, different hardware in a different data center, and this replication is a link between them. It's configured on a per bucket basis. It can be either unidirectional or bidirectional. It is multi-master, where writes and reads can happen to both clusters independently. There is some very simple conflict resolution in the event that you write to two locations at the same time. But generally, most of our use cases and customers tend to find that you won't be writing or changing the exact same pieces of data at the exact same point in time. Keep in mind it is different from intra-cluster replication. So within a cluster, we have very high speed replication for the purpose of high availability, and it is strongly consistent, whereas across clusters, it is more for disaster recovery or geolocality of data to push your data physically closer to your users. And this is an eventually consistent replication between the two clusters. Again, taking a look at how this works on a single node. When a write comes in, the same process again, it's put into cache, replicated out to other nodes, persisted to disk, and then once on disk, it's picked up and sent over to another cluster via our cross data center replication queue. One of the main benefits here is that multiple writes into RAM will be deduplicated before they are sent to disk, and therefore we are saving the cross data center replication and saving your bandwidth by not having to transmit every single write that may be overwriting data that you don't care about or don't need anyway. Taking a look at how this operates across a cluster, if we have one 3-node cluster in New York and we set up another 3-node cluster in San Francisco, or this could be Ireland, this could be Singapore, this could be South Africa. There are connections automatically made from node to node, so there's no gateway to set up, there's no extra process or extra server to run and scale. As writes are made, they're automatically sent off of the disk of one cluster into the RAM of the other, and persisted down to disk on that side. Throughout this whole process, both of these clusters can be rebalanced, added to, or shrunken. Failures can happen on either side, and there's no disruption to the replication. The last thing that we've introduced as a beta is our full text search integration. So we're using Elasticsearch for ad hoc queries and faceted navigation. Actually uses our cross data center replication feature to push the mutations into Elasticsearch, and then the Elasticsearch can be used to query that. So what that looks like in this way is the application server at the moment has a connection both to the Couchbase server and to the Elasticsearch cluster. And all of the data access is being stored in Couchbase, whereas the Elasticsearch cluster is just returning references to the documents after you perform a query that can then be gathered from the Couchbase server cluster. Over time, we will be enhancing this integration and adding a unified SDK and API so you don't have to manage both clusters independently. Okay, so as quickly as I possibly could, I got through all of those details. I'll now open it up to the group there. If you want to submit your questions via the GoToWebinar question interface, I will spend as much time as you need to get all your questions answered. So thank you very much for listening, and feel free to send your questions over. So the first question I have here asking about indexes and queries and the performance of queries. The one thing to really keep in mind is that queries are always done off of the pre-materialized index. So there's never a time where your query is going to generate extra load on the cluster by regenerating or causing an index to run. It's just requesting the data that's already been populated, and then it's up to the cluster and the performance of the nodes to make sure that stays up to date. Another question about the consistency of your writes being represented in the indexes. By default, we do everything asynchronously, where you are reading and writing individual documents, and those are being eventually persisted to disk and eventually caught up in the index. We do have an operation called observe that allows an application to know when an item has been persisted to disk. And so if you want to deal with the performance difference of waiting, you can be much more consistent about when an item is written into cache, when it's written into disk, and when it's available for the index. And by doing that on a per document basis, the application developer can trade off the difference in performance versus the consistency. A question about cross data center replication. What happens when the connection is lost or is slow between the two clusters? This is another benefit of having the replication come from disk. We don't need to maintain any queues in RAM when either the connection is slow or is disconnected. So the stream will just go as quickly as it can get off of disk and over the other side. We use sequence numbers on disk to make sure that we can start and stop the replication without having to resend all of the data. And because it's on disk, anything that is written to RAM will get deduplicated before it is sent to disk, even further reducing the I/O. Another question coming in about the sizing of a cluster and the differences between Couchbase Server 1.8 and 2.0. I wrote up a pretty long write-up that's going to be released in a couple weeks about the impact that these features have. One of the best things is that there really is no change in performance for your individual reads and writes into and out of cache. That's coming from our long history of working with Memcached and the fact that we can provide sub-millisecond response times at very high throughput, even in the face of heavy disk I/O or CPU load. And so with the new features, with the indexing and querying, with the cross data center replication, those are definitely using more resources of the system, and you will have to size your cluster a bit differently if you want to take those into account. But you can be sure that the performance that you've always had on Couchbase Server 1.8 is going to be the same. Another question, can you recommend a method of exporting views from a development server and importing them into a production server, either by SDK or REST API? Yeah, so let me talk about this in two ways. You're asking about a separate cluster or a separate server. And so our REST API has the ability to query the views and get the view definitions out of one server and into another. Our backup and restore tool also has the ability to grab those view definitions and import them into a new cluster. Some of the SDKs are being built up so that they can actually define the views in a more programmatic API way. And so you've got a couple different options for depending on what you need to do, how frequently you need to do it, how dynamic those changes need to be. Another thing that I didn't talk about in the webinar is the way that we create views within Couchbase Server. So you have what's known as a development view and a production view, and on the same cluster, on the same data set, you define your development view that only operates on a very small portion of the data set. It doesn't put extra load on the cluster, and it doesn't take very long to run because it's working off of a small portion of your production data set. But it lets you work off of the actual data. And then when you're ready, you can materialize that view and in one click automatically push it into production. And by pushing it into production, you can no longer change that view because it is locked down so that the application can always rely on it. And if you want to change or edit that, it's a very easy process to copy it back into development, make any changes, iterate on that a few times, rematerialize it, and then push it back into production. So there's some documentation and some webinars about how to do that. And certainly if you send me an email or take a look on our forums, we'd be happy to guide you in that. Okay, I'm going to take a quick drink of water. Please feel free to send in any of your other questions. Like I said, this webinar has been recorded and will be made available so you can view it offline at your own leisure. And you certainly have my contact information if you have any questions. Again, I'm based in London, looking after our UK and European and Eastern European customers. So I am your technical resource in whatever questions you may have. If you haven't had a chance already to download Couchbase Server, it was made GA about a week ago. We've been having really good success with the customers that have taken it on, and it's gone through some very rigorous QA and performance regression testing. We really feel that it is one of the best releases we've put out so far, and look to have lots of people playing around with it and developing their applications on top of it. Okay, I'll give us all a few more minutes. If there are any other questions about anything related to Couchbase, please feel free to send them over. Question about upgrading from Couchbase Server 1.8. We've tested, certified, and support a rolling upgrade. So all you have to do is add nodes of 2.0 to a 1.8.1 cluster, rebalance, and remove the older version. And then once everything is at 2.0, you will have the full capabilities of there. So again, that can all be done online. All of the server is backwards compatible with all of the client libraries, and all of the client libraries are compatible with both 1.8 and 2.0. And another question about upgrading. Even if you are, sorry, the question is about binary data versus JSON data. Couchbase Server 2.0 is just as good a key value store as it is a document store. And if you are not yet storing your data as JSON, or for some reason you want to store your data in another format, the Couchbase Server 2.0 will take that in and handle it just as well as 1.8 does. You don't get the ability to create indexes and views off of the data within the documents. However, you can still perform queries off of the key names. So if you're doing things like prefixing your keys, or there is some logic within the naming of your keys that you want to filter or query off of, you can still do that even though the data is binary. Okay, a few more minutes. Please feel free to send over any other questions you may have. Is there anybody out there already running Couchbase Server 2.0, either in test or in production, that you'd like to share some of your experiences, or have me help you look at any questions or use cases you may have? Okay, well, if there aren't any other questions, go to couchbase.com and download our Couchbase Server 2.0. There are developer resources and tutorials and lots of other webinars that you can view and get much more information from our documentation and our presentations about the software. So with that, I thank you all for joining me today. And please do let me know if you have any other questions or there's anything else I can do for you. Thank you very much and have a good day.